Hello, this is Dr. Mears. Today we are going to be learning about logarithmic models. Here you see my favorite picture right on the first slide where we have the exponential function f of x equals 2 to the x, and then we have the inverse exponential, which is our logarithmic function. We can say f of negative 1 of x equals log base 2 of x, or we can say y equals log base 2 of x in our imaginary line, where if we folded the paper on this line, this blue curve would be on top of the red curve, and yes, we would have a purple curve. All right, without any further ado, let's go. All right, so as you see here, we have a logarithmic scale with base 10. And this is what we looked at the other day. This would be 10 to the first, 10 squared, 10 to the third, 10 to the fourth, 10 to the fifth, where it's not a linear scale. We're not just going by a linear scale. And so under a logarithmic scale, each successive unit gets multiplied by a common factor. In the picture above, we have a common ratio of 10 that results in a scale like in the diagram. The word logarithm basically translates to ratio number. Here we have an example. We have log base 10 of 10,000 equals 5. That really represents, if we undo the log, if we inverse the log, this really is 10 to the fifth equals 10,000. When we write log base 10 of 10,000 equals 5, we are really saying what power of 10 will give you 10,000. So this right here is what power of 10 will give you 10,000. We can clearly see that in 10 to the fifth, that equals 10,000. That power of 5 will give you 10,000. There are other ratios besides 10, and that's what we're going to be looking at today. Examples of other ratios. Here we have log base 2 of 8 equals 3. This is transformed into 2 to the third equals 8. The reason why I keep calling 2 as the base, because that's what it is. 2 is the base, and 3 is your exponent. So when I say log base 2 here, I'm really talking, it really is log base 2. Okay, let's see number 2. Log base 5 of 625 equals 4. This is transformed into 5 to the fourth equals 625, which is true if you did 5 times 5 times 5 times 5. That is going to give you 625. Here, if you did 2 times 2 times 2, this is going to give you 8. It's just how many times we multiply to get that number. All right, now it's our turn. Let's transform. Here is the trick, and I put the trick over here. The trick is b is your base, so that is going to be that bottom number. Then you're going to raise it to, this is going to be your exponent. So this is your base, and this is your exponent, and this is going to be your answer. So pretty nice. B for base, x for exponent, a for answer. So let's see. We have log base 2 of 216 equals 3. So 6 is your base, 6, okay. 3 is your exponent, and here's your answer, 216. And if you did that in a calculator, 6 times 6 times 6 does equal 216. Let's do the second one. Log base 7 of 49 equals 2. So 7 is our base, 2 is our exponent, and that's going to equal our answer of 49. And that is true as well. All right, now we have to go backwards. So now we have to take 8 to the third equals 512. Well, let's write down log. I'm just going to erase this. Okay. Log, what is our base? Our base is 8. What is our answer? Our answer is 512. And what is our power or our exponent? That is 3. So base, exponent, answer. Let's do this one. 3 to the fourth equals 81. Okay. Log base 3, answer 81 equals our exponent of 4. There we go. You have now transformed from logs into exponentials and from exponentials into logs. Congratulations. Let's move on. If you must pause here and rewatch the video just so you can pick up my trick again, that would be highly recommended. For anyone, it'd be highly recommended. All right. Now let's find x. Notice these all look alike. I did that on purpose. I wanted you to see how we can manipulate our exponential equation and our logarithmic equation. So I'm going to do these underneath here. I'm going to do number 1. And number 1, we have 5 to the x equals 25. Well, here's the thing. Let's first change this. Actually, no, you know what? Let's think in our heads. We have 5 raised to some exponent to equal 25. Well, what are we going to have? We have to multiply 5 times itself a certain number of times to get to 25. And a lot of people already said 5 times 5. And you're right. 5 times 5 does equal 25. So how many times did we have to multiply it? Well, we had to multiply it twice. So we find 5 squared equals 25. Excellent. So you could just write down x equals 2, and you would be correct. You can also think about it in a different way. You can think 5 to the x equals 5 squared. Now that these two have the same base, guess what happens? The bases drop out, and we simply get x equals 2. So if you wanted to think about it using your mental math, 5 squared is 25, absolutely fine. If you wanted to do it where you had to change these to the same base, absolutely fine. Let's go to number 2. We have log base 5 of 25 equals x. Now we can do this in a calculator because here's the thing. This base right here, that is not, we don't have base 10. In your calculator, you have the log button. The log button is right here. It's the 1, 2, 3, 4. It's the 5th one up. I think it's the 4th one on a regular calculator, handheld one. This is from my phone. I'm using my phone handheld calculator. And so you see log here. So we were going to be able to solve this really easy. So let me show you how to do it. So in order to solve where we don't have a base of 10, and on your calculator, this log right here, that's base 10. So we have to kind of get out of base 10. So what you do is you take the big number, 25. That's your answer. Remember, that's your answer. So we're going to do log of 25 divided by log of the base, which is 5. It's always going to be the log of the answer divided by the log of the base. And if you want to write that down for notes, the log of the answer divided by the log of the base. And the answer, I'm talking about 25 here. Remember, that's our answer there. Or we can even say, log A divided by log B. Well, this is A and this is B. Okay, so we just now took it out of that base 5. So let's do log 25, okay, divided by log 5. And notice I did close my parentheses here, so be careful because you do want to close your parentheses after 25. Enter. Oh, 2. Excellent. So 2 equals x. That is amazing. And so I don't want to confuse people. I might get some feedback saying, wait, the answer. So you know what we're going to do right here? This is what we're going to do. We're going to do something. We're going to do this and this. And that is actually going to equal, log A, like that, log B, A. Okay, so for those visual people who really like to see it, so you take the log of A and you divide it by the log of B, and this is what you do in your calculator. Okay, number 3, x squared equals 25. Number 3. X squared equals 25. Well, now you know, right? Oops, sorry. Now you know that 5 squared equals 25. Excellent. You also could have taken the square root. And I'm not going to get into taking the square root right this moment. I'd rather have you transfer this over. If we were going to transfer this over, it would be log base x of 25 equals 2. You could transfer it over like that. Or mental math. You can use mental math there as well. All right, let's try number 4. Number 4 is right here. Oh, look at that. Oh, look. Log base x of 25 equals 2. That's the one that we just did down here. So you know what? Let's transfer it over so that we can do mental math. Base is x. Exponent is 2, 25. And we know 5 squared equals 25. So x equals 2. Nope, sorry, x equals 5. And the last one, number 5. 5 squared equals x. Yes, everybody knows 25 equals x. And we're done. Okay, so again, if you want to go over these, I'm thinking number 1 and number 2, these are your most important number 1 and number 2. So go back over. Make sure you know how to do this in the calculator. Make sure that you know how to do log A divided by log B to get an answer. We are going to need this coming up. Next. So here's some other examples using log when 10 likes to hide. The base 10 likes to hide. So make sure you do have your GDC. So right here, 2 plus log of 3. This is base 10. So we could have written this out as 2 plus log base 10 of 3. So sometimes that 10 likes to hide. Now, we can just do this in our calculator because it is base 10 here. Let's just go to our calculator here and we can clear this out. We're going to do 2 plus log, and then we have 3 and parentheses. It's base 10 already in our calculator, and we get 2.477. I'm going to round to the nearest hundredth, so I'm going to do 2.48. So the answer here using your graphing calculator is 2.48. Done. Okay. Find the value of x when log base 10 of x equals 1. So here's where you really need to use base 10. Here's where you really need to put the 10 in and rewrite it because we have to take it out of logs. So this really transforms to log base 10 of x equals 1. So you have to know when there's no little tiny number there, it is automatically 10. It likes to hide. So let's now rewrite it. This is really 10 to the first equals x. And well, 10 to the first is 10, so 10 equals x. Okay? Pretty please. You have to remember that. Again, here, find the value of x when log base 10 of x equals 3. It likes to hide, so you need to rewrite it with it in there. Because then once we take it out of the logs and put it into exponential, we're going to get 10 to the third equals x, and 10 to the third is 1,000. And that's our answer. So if you can remember, it likes to hide. When you have problems, when there's no little base number here, you need to put the 10 in. If there's a number, you'll see it. It'll be there. Okay, next. Another base. This is known as a logarithm e. So here's where if you were not grasping the concepts that we just went over in the previous couple pages, you might want to pause, go back over, maybe retry those examples on your own, and then come back to this part because I'm introducing to you the natural logarithm. So it is denoted as ln. You're going to see that in your calculator. In your calculator, it actually is the one underneath log, and it's capital L, capital N in your calculator. In your book, you're going to see it as ln. Is known as natural logarithm and can be denoted by the letter e. So watch, I'll show you. E is an irrational number. That means it is a decimal that does not stop or repeat. E equals 2.718281, so on and so forth. So here we're going to see it. E to the x equals b. So this is this number. So this is really 2.7182818285 ... to the x equals b. But this number has come up so much in mathematics that the mathematician said, we're naming it e. So instead of writing all of this out, they shortened it to the letter e. We can transform this log of e, base e of b equals the natural log of b to ln, to the natural log of b equals x. What the heck do I mean that things? I'm going to explain right now. So what we have here is log base e of b equals x. So that's the first part that we have. If we transformed this, it would be transformed to e to the x equals b. Excellent. Okay, so in log form, in exponent form. Now in log form, because log of base e, this is actually, this whole entire thing now transforms into a natural log. So now this log base e transforms into the natural log of b equals x. So these combine, poof, make the natural log. So here on your calculator, you're going to see, Here we have the natural log, and above it, you're going to see the blue key. It says e to the x. I'm not sure if it's going to focus in on that for you. So we have both of those in our calculator. We can use the natural log and e to help us find exact values of x, so grab your graphing calculator. This is what I mean by how it's going to help us solve. Solve the equation e to the x equals 4. So what we need to do is we need to undo the e by taking the inverse. We're going to use that nice natural log of b equals x to write and solve. I actually gave this to you, but you know what? I'm going to do it all out. So I'm going to say here's e to the x equals 4. We have to solve for x. So what we can do is we could do log base e of 4 equals x. So remember, log, here's the base, here's the answer, and here's the exponent. That's the lessons that I just did, and that's why I said if you don't understand the lessons that I just did, to go back, because I just transformed this into a log, from exponential into a log. Now, this log base e, it becomes our natural log, our ln. So ln of 4 equals x. And in our calculator, we can get our calculator here, and we can press the natural log. Natural log comes up, 4, enter, that's our answer. X equals 1.3, I'm going to round it 9. So all I did in my graphing calculator was I pressed natural log of 4. Done. Once you can put it into logarithmic form, and remember that log base e is a natural log, then you're able to do these really quick. Okay, so here we go. This is definitely what you need to know. All right, moving on. Again, I know we're doing this during class, so I know you're watching the video, so please make sure to stop me if you have questions, chat box me, because I am here to help. So let's do some examples using natural log. Need our graphing calculator, so grab your GDC. This, again, can be simply put into our graphing calculator. So we can put 0.5 plus natural log, let's do it again. 0.5 plus natural log of 3. 0.5 plus natural log of 3. Press enter. 1.5986. Let's round to 1. We could do 60. We can do that. So this was approximately 1.5986, which we can round to 1.60. That's absolutely fine. Okay. All right. Now, find the natural log of x equals, find x if the natural log of x equals 4.2. So what we're going to need to do here is we are going to need to exchange our natural log for, you guessed it, log base e. So we're going backwards. So log base e of x equals 4.2. So remember, log base e from our previous sheet, log base e of b equals x. These are interchangeable, and so are these. So please be careful. So we have log base e of x equals 4.2. So all I did, I'm sorry, I rewrote it twice. So log base e of x, log base e of x equals 4.2. So now what we can do is we can transform this into e raised to the 4.2 equals x. And we can write this over. So what am I using? I'm using all these rules now. And that's exactly what I was actually going to write down. I use log, natural log of b equals x. This is where I started. Then I changed the ln over to log base e. Now what I'm going to do is e to the x equals b. So these are my 3 transfers that I need to be able to understand. This might be something that you might want to write down in your notes. So now we can do this in the graphing calculator. Clear that out. So in order to get E is a secondary key because it's blue. So what I'm going to do is I'm going to push second, and then I'm going to push ln, which is natural log. And that's where your E comes up. And I'm just going to push 4.2 and then enter. 66.686, all these roundings. So let's round to 66.7. 66.7 equals x. So let's go through this one more time. We had natural log of x equals 4.2. I took the ln and I changed it over to log base e. Log base e of x equals 4.2. I kept those the same. Then I said, okay, can't really do anything with that, so let's change it into an exponent. So base e to the exponent equals x. I was able to do it in my calculator, and remember, in order to get the e, you have to press second natural log, second ln button, and that will give you the e to the x button on your calculator. Okay, all right, let's try this one. This one doesn't really look like a natural log one. Actually, we don't have to transfer it back to a natural log. What we do have to transfer, what it looks like, is we have to transfer it from exponent back to log. So log base 3 of our answer, 5, equals x. So remember, 3 is the base, then the answer goes, and then equals the exponent. And so this is bringing us back. I just spiraled back to what we did in the previous slide. In order to find x, we have to do the log, you got it, of 5 divided by the log of 3. I always remember which one goes on top or in the numerator because this is kind of the number that is on top and this is the number that's on the bottom. So log base, the number on top, divided by log base, the number on the bottom. You know what I'm, so that's how I remember it. And so now in your calculator we can do, don't forget you're pressing log now, log base 5, I ended my parentheses before I press the division, and then log of 3, 1.464. So let's round to 1.46 equals x. And there we go. Ooh, let me move down. And there we go. So calculator, this was the foundation of making sure you can transfer to each of these, and then looping it back into one of our skills we had before. If you would like more practice, please chat box me right now, Schoology message me right now. I will give you some examples to practice. We're doing this together, so definitely ask for help. I am here for help. So exponential and logarithmic graphs, they're two different stories. This is of coronavirus cases, and I just wanted to kind of pop a real world example on you. It's like, why do we need to know logarithms and exponents? Well, because you have to understand that it tells you two different stories. So this was from February 18th to March 19th, and this was the exponential curve, and this is what we've been looking at. And when we look at the exponential curve, we see that US, it looks like it's pretty far behind Italy. Okay, let's now transfer from our exponent equation to our log equation. Okay, so we're transferring from our exponent equation, we're transferring from, we're transferring from a to the x equals b over to log base a of b equals x. So we are transferring from this over to this, from this picture now to this picture. Same dates. Look at what happens. It looks like they're so far away here, but based on our logarithmic functions, our US is catching up to Italy, and that was on March 19th. Okay, exponents and logarithm graphs, two different stories. What happens with that transfer? You can definitely see we got actually closer than we actually thought. All right, so let's look at some real world examples. So we have the spread of a virus can be modeled by the equation f of x equals 10 to the x, where x is the time in weeks. Part A, find how many people have the virus after 2 weeks. Remember, we can also write this as y equals 10 to the x, so don't be fooled. And I'm just going to write down x equals weeks. And then our f of x here is number of people with the virus. Okay, so find out how many people have the virus after 2 weeks. 2 weeks. So X is weeks. So X is going to be 2 here. I'm annotating. So we have to use this function and put 2 in where the X is. So let's use the function and put 2 in where the X is. So we have f of x. So we have inputting f of 2 equals 10 squared. So f of 2 equals 100. So we know 100 people have the virus after 2 weeks. There we go. Perfect. Complete sentences, please. Okay, part B. Find the number of weeks that it takes for 500 people to have the virus. So now what we're doing is we're looking to see, find the number of weeks. So we don't know what X is, but we do know the people. We do know that f of x equals 500. So now we're not taking out the x, we're actually going to be taking out the f of x. What does that look like? That looks like this. F of x equals 10 to the x. Don't touch the x. We're taking this out and putting 500. It's replacing that whole thing. Equals 10 to the x. This is tough because even if you put in any number here, it's tough to get 500. This is going to be a decimal. What do we need to do? You're right. We need to use logs to solve. Let's do that. Now, if you remember, it's going to be log the base. What is the base? The base is 10. What is the answer? The answer is 500. And what is the exponent? X. If you could remember that, the base, the answer, and the x, you can transform it anytime. So now you're absolutely right. We need to use our calculator. We need to do log of the number 500 divided by log of 10, and that's going to equal x. And when we use our calculator to do that, we're going to get 2.70 equals x. And so that's the number of weeks. So we have 270 weeks for 500 people. 2.7, Dr. Mears. 2.7 weeks for 500 people. I'm like, wow, 270 weeks, that's a long time. With a function like 10 to the x, 2.7 weeks, wow, for 500 people to have the virus. Awesome. Okay, why don't you try the next one? Because it's pretty much the same. Let's see. Find the number of weeks. So we need, again, we don't know what x equals. It takes for now 2,000 people to have the virus. So let's use our model. Just like we did here, we're going to be substituting the 2,000 now in for f of x. So why don't you pause right now while I'm writing this out and try it yourself and then come back. Okay, you got it. X equals 3.30. Excellent. Now, I know some of you are saying, wait a minute, we're actually in base 10. Isn't our calculator in base 10? And I'm going to tell you, yes, it is. I actually had you do this process to get used to doing this process because we're not always in base 10. So could you have just in your calculator pushed log and then 2,000? Yeah, you could have, but it's very easy for young mathematicians to forget that the calculator is always in base 10. So there's your 3.30 weeks for this answer, but the calculator is always in base 10. So what I do is I try to help the students always just do this process, even if this is base 10, because most likely it's not going to always be in base 10. It might be base 2 or base 5 or base 3. So pretty please be careful when you're using your calculator. It's always good to just do that extra step because it trains your brain just to do that extra step, especially when first learning this. Let's do natural logarithm real world examples. Here we go, a funny joke told on Good Bad Joke Friday. Oh, I wonder where they got that from. Is spreading through school. The speed that it is spreading can be modeled by the equation f of x equals 4 plus e to the x, where x is the minimum time, is the time in minutes, and the time in minutes is greater than or equal to 0. So we're not doing, there's no negative time here. That's what this is saying. It's the time has to be greater than or equal to 0. So x is minutes, and x has to be greater than or equal to 0, so no negative x's here. Find out how many people heard the joke initially. This is a big word, initially. You really have to train your brain when you see the word initially. What the problem is looking for is when x is 0. So when something just starts off, it's basically, you're right, your y-intercept. So when they ask you for initially, they're looking for your y-intercept, and that's when x is 0. So we do have to substitute 0 in. 4 plus e to the 0. And you can do that in your calculator. You can do 4 plus e to the 0. And when you do 4 plus e to the 0, you are going to get 5. So 5 people heard the joke. First heard the joke. Okay. Find out how many minutes before it took 150 people to hear the joke. So now they're looking for how many minutes. So we don't know what x is. So you're right. We are going to have to substitute 150 where the f of x was. And now we become a solving problem. So instead of f of x, you're going to substitute 150. So you take that out because we don't know what the minutes are. So let's substitute 150 in. Now, in order to find what x is, we have to undo addition and subtraction. And I'm really hoping that throughout the years of math, you're like, subtract 4. That should subtract 4, get rid of that addition subtraction. So you're right, we subtract 4. So we have 146 equals e to the x. And I hope you are remembering that we can't really do anything here. And you're right, we have to turn it into logs. So let's turn it into logs. So hopefully you're seeing a pattern. So we have log, what's the base? The base is e. Good, what's the answer? 146, excellent. What does that equal? That equals the exponent, which is x. And then you need to train your mind. What is this? Wait a minute, we have that button, that natural log button on our calculator that we can now take log base e and turn it into our natural log. What are we going to come up with? We're going to come up with about 4.98, my bad, 4.98. So we're talking about, you can say about 5 minutes. If you want to do 4.98, that's absolutely fine. There you go. This is a really nice problem. Again, please ask questions. Okay, now you try. So again, you might want to pause the video. What I'm going to do is I will run through it. So pause the video, and once you unpause, you're going to see me going through it. Good luck. All right, the length of a pumpkin plant in meters can be modeled by the equation f of x equals e to the x, where x is the time in weeks after the pumpkin is planted. So f of x is going to be the length in meters. Metres, I left out metres. European. Find the initial length of the pumpkin plant. Initial, my brain now knows x is going to be 0 because I remember initial is going to be when x is 0. So I'm going to substitute in 0. And then I'm going to do e to the 0 in my calculator, and I'm going to get 1. So 1 meter. Length. I'm always used to doing height. Length. Okay. Find the number of weeks it takes for the plant to reach x meters. So we don't know what the x is. So I'm going to have to substitute in 10 for the x, 10 meters, because I don't know what x, 10 for the f of x. I do not know what the x is, so I have to substitute 10 in for this side. So 10 equals e to the x. Absolutely right. What are we going to do? Let's change it out. We need to change to log. So log, what's the base? The base is e. What's the answer? 10 equals x. Absolutely right. We now know log base e is natural log. I could do this in my calculator. Press ln, 10, and then we're going to get 2.30 equals x. So that is 2.30 weeks. for the plant to reach 10 meters. There you go, and that's your answer. This has been Logarithmic Functions. Pretty please go back, review what you need to review, and ask questions. Ask for more examples. I have them, and we can go through them, and I hope this helps. Thank you very much.